Hi everybody. We're going to move on to Newton's second law today. We already learned about Newton's first law the other day, and that was for an object in motion stays in motion, an object at rest stays at rest unless there's a net force. So rest or constant motion unless there's a net force or an unbalanced force. On to Newton's second law. He has three laws, but today is Newton's second law, and it's really just an equation, and it's really probably the most important equation in all of physics. It's that a net force equals a mass times an acceleration. It's that equation. Net force equals mass times acceleration. So, for example, if you have a box and you push on it with a certain amount of force, that box, net force I should say, that box is going to accelerate. Okay, it has a net force. That acceleration can be measured. If you applied that exact same force, so I'll draw a little tick mark here, for the same net force on an object that's much larger, has a much larger mass, it's going to have a smaller acceleration. Okay. If you look at the equation, F net equals ma, for a given force, the bigger the mass is, the smaller a is. These two letters, we call it as an inverse relationship between mass and acceleration. The bigger the mass, the smaller the acceleration, and vice versa. If something had a really small mass, it would have a really big acceleration for the same force. Let's do an example. Let's say we've got an applied force to the right that is 10 newtons. We've got a force of friction to the left. Let's say that that's 2 newtons. Our object's mass is going to be 4 kilograms. And we want to know the object's acceleration. So, to find the acceleration, we use Newton's second law. It's just an equation. The mass, m, would be 4 kilograms. A, we don't know, so we'll leave that as a variable. Net force, we've practiced doing that already. You look at the direction that the thing could move. It's going to move left to right. You've got 10 newtons to the right. You've got 2 newtons to the left. So the net force, you just subtract them because they're in opposite directions, would be 8 newtons. Now to solve for A, you divide 8 by 4 and you get 2 meters per second squared. And that'll always be in the same direction as the net force. So if the net force was to the right because there's 10 newtons right compared to only 2 to the left, that means our acceleration is to the right. Now, to go back to the diagram for this same question, you should also be wondering, hey, there's other forces acting on this block, right? You've got the weight of the object pulling down, and you've got the ground pushing up. We call that the normal force. Since the block isn't going up or down, these two forces are the same. They're balancing each other out. There's no net force up or down. And something we're going to start calculating is how much does something weigh? How do you figure out weight? Okay, weight is different from mass. Mass is how much stuff something is made of. Weight is how that stuff gets pulled by gravity. How the mass is pulled down by gravity. So weight has to do with gravity. Mass does not. To calculate weight on Earth, all you do is take the mass of the object and you multiply it by the gravitational field strength of Earth, which we've already seen this number before. It's the same as the acceleration of things in free fall. It's the number 10. So to find the weight of an object, you take its mass times 10. So going up to our example above, the weight of our object, if its mass is 4, its weight would be 40 newtons, which means the normal is also 40 newtons, because those two forces are balancing each other out.